right, let's write it down. F of x is the natural log of x. F prime of x. Well, that's going to be 1 over x. I'm just going to write it as x to the minus 1. F double prime is going to be minus 1 x to the minus 2. F triple prime is going to be 2 x to the minus 3. The fourth derivative is going to be 3 times 2 x to the minus 4. Let's evaluate. F of 2, natural log of 2, f prime of 2, I can write it as 1/2. F double prime at 2, I'm going to write it down as minus 1 over 2 squared. F triple prime of 2 is going to be 2 over 2 cubed. It's best not to simplify until you see a pattern. Fourth derivative, 2 is going to be 3 times 2, which is 3 factorial, over 2 to the fourth. I made a mistake in sign, though. I know they're alternating. Let's see, plus. This one's going to be minus. Sorry about that. Let's write this down what I think I'm seeing anyway. And I'm definitely seeing powers of 2. 2, 1, 2, 2, 2, 3, 2, 4. I definitely see an alternating as well. So plus, minus, plus, minus. What goes on top? 3 factorial, 2 factorial, 1 factorial, 0 factorial. So I think I got the pattern. Let's write it down now. So the natural log of x, whoops. Let me get that a little better. Be consistent. Well, it's going to be the natural log of 2. We just did that. And it's centered at 2, right? So it's going to be x minus 2 to the 0. Let's put the next term down. And looking at it, that's going to be 0 factorial over 2 to the first power, and then x minus 2 to the first power over 1 factorial. Let's put the next term down. That's minus. That's going to be 1 factorial over 2 squared, x minus 2 to the 2 over 2 factorial. You get a feel for it now. And this does go on, by the way. And the feel for it, ln x is going to be the natural log of 2. And then I got this pattern over here. And I think I'm ready to go with it. And what am I seeing? I'm going to start writing it down now. I'm seeing plus, let's see, x minus 2 to the first power. And then I see this 0 factorial, 1 factorial, so it's going to say 1. And then it's going to be minus x minus 2 squared, 2 squared, and 1 factorial, 2 factorial on the bottom just gives me a 2. Next one would be x minus 2 cubed, 2 cubed, and then when you get there, you get 3, right? So forth and so on, all right? I know it's alternating. I think I'm ready to write down the sum, and that's natural log of 2. It looks like a limit, doesn't it? Natural log of 2 plus the sum, n equals, I'm going to start at 0, go off to infinity. And what do I see over here? Well, let's count one rabbit at a time, and let's do the 2 to the power. It's going to be 2 to the n plus 1. I see x minus 2 to the n plus 1. And then what else do you see? They see that 1, yeah, n plus 1. All right? So I think I got that covered. And the next thing I want to do is the alternating part. Let's put that down. So minus 1. It's got to be positive. Let's put n over here. And I think I have it. I think I got what I need. And by that, I got the series expansion for it. And the question is, what else do I need to do? I need to get the radius and interval of convergence. And looking at it, I'm going to do the ratio test. Limit as n goes to infinity. Whoops, that doesn't look right either, does it? I erased it all together. Limit n goes to infinity minus 1 to the n plus 1 times x minus 2 to the n plus 2, 2 to the n plus 2, n plus 2 times 2 to the n plus 1, n plus 1, and then minus 1 to the n, x minus 2 to the n plus 1. Limit n goes to infinity. These things aren't paying much attention to because they're going to, absolute value, there's just one. This, I'm going to cover this now. And what's that going to be? That's going to be 2 on the bottom. I'll do this next. And that would just be x minus 2. And it's the absolute value of it. And then I got this over here, which is n plus 1 over n plus 2. This limit is going to equal the absolute value of x minus 2 over 2, and that should be less than 1. And what does that mean? The absolute value of x minus 2 is less than 2, which means x minus 2 is between 2 and minus 2, which means the x is between 0 and 4. I want to test the endpoints one at a time. Let's test the 0 first. You know what? Let's test the 4 first. And what do you get there? And you may wonder where I'm plugging it in, right over here. And what's that going to be? Well, if you plug that in, again, I'm testing the 4 out, x equals 4. You get this over here, n equals 0 to infinity, minus 1 to the n, and that would be 2 to the n plus 1, over 2 to the n plus 1, n plus 1. These cancel off, and you get a convergent series there. So I'll include it. Let's try the 0, x equals 0. And we'll try that in the sum. N equals 0 to infinity. That'll be minus 1 to the n. And I'm trying 0, so it's going to be minus 2 to the n plus 1 over 2 to the n plus 1, n plus 1. A simplification here. N equals 0 to infinity. Minus 1 to the n, minus 1 to the n plus 1, and then you're going to get 2 to the n plus 1 over 2 to the n plus 1. They cancel, n plus 1 here. And what do I know about this over here? It's going to be 2n plus 1, so it's always odd. And this is going to just be divergent now. So I got my interval now. Let's write this down. The radius is 2. And the interval starts from 0, but don't touch it, and it goes up to 4 and includes it. So this is my series expansion for it right over here. All right, I do recommend looking at the key, particularly problems that you're having trouble with, and see if you got it right. This is number 22. And let's take a look. Number 22, I do see the natural log. I do see the sum as n goes from 0 to infinity, minus 1 to the n, 2 to the n plus 1, n plus 1, x minus 2 to the n plus 1, radius being 2, and the interval we got. We're good to go. Thank you.